Hello, and welcome to Digital Dumpster Diving. I'm Corey Ham, and this is my talk about PasteHunter, data aggregation and web scraping, and the general state of OSINT and data processing. I hope you're enjoying Source Zero Con. I think it's really cool that we have our own con now, especially since it's offensive security focused. I hope you enjoy the talk. And just so you know, this is pre-recorded, so I won't be able to actively respond to questions during the talk. I will be in the Discord answering questions, and I should be live after the talk to answer any questions that remain after. So here we go. So here's the agenda. We're going to start with an introduction. That's what we're doing right now. Then we're going to cover the backgrounds of data mining and web scraping. So I like to kind of level set when it comes to these complex terms or buzzwords, just to sort of explain where we're starting so that everyone can build on the same foundation. Then we're going to cover a simple scraping example that I designed specifically for this talk. It is just scraping data from a tattoo shop and then doing some very simple processes on it. Then we're going to cover PasteHunter, which is a tool that is designed specifically to scrape from Pastebin, from GitHub, and from a few other sites. We're going to run through the architecture of how that tool works, how it processes data, how it stores data. We're going to talk about various Paste sites, what data might be present on them, what data won't be present on them. And then lastly, we'll cover some takeaway concepts when it comes to OSINT and pasted data that I think is relevant for anyone that does OSINT or anyone in offensive or defensive security especially. Then I'll cover some general thoughts, talk about the future of Paste sites, and lastly we'll do any questions that anyone has. So who am I? I am Cham423. Corey Ham is my real name. I don't use Twitter, but you can hit me up on Keybase or Discord, or you can follow me on GitHub. It's pretty much the same name everywhere, so I should be pretty responsive if you reach out to me. I've been doing offensive security at Optiv for 4 years. I've been doing offensive security my entire career, actually, but at Optiv I do adversary sim, research and development, and consulting. I sort of started out as just a normal consultant, and now I've worked my way up to a tech manager title, which is still a consulting role, so I'm still just doing pen tests and other engagements as they come in. I've been pen testing since 2013, so I have a background in security. I've always been an offensive security side, but the blue team side of the fence has always interested me as well. I have a networking degree, which has sort of paid for itself. Luckily, I went to college before there really were common security degrees. And my hobbies are hoarding data, filling up hard drives with whatever I can find, electronic music, cars, and mountain biking. So feel free to drop a line and we can talk about those topics in the Discord. So who is this talk for? I like to sort of advertise my audience, who I built this talk for. I do think it could apply to pretty much anyone, but for red teamers, this talk will help you collect operationally useful info. What that means is info you can use during your gigs. For blue teamers, this talk can help you learn about information exposure and leaks and just concepts that attackers like me would use. And for anyone else, you can learn the concepts of data mining and use them to make your life better. That may apply to the tattoo shop example. That definitely made my life better just with a simple piece of code. Some helpful background knowledge that will sort of make the talk easier to understand. Python and general coding concepts. We're not going to be going too deep into the weeds with code and design and things like that, but it is good to know the basics of how for loops work, how these libraries function, and just the general architecture of a script like this. And then Linux is great. Knowing the concept of how like services are created and admin and Docker and things like that are going to help you run through the PaceHunter tool a lot easier. Elasticsearch, not required. Any sort of SIM knowledge would be required, or helpful. But Elasticsearch specifically is a tool that I use to index and store the data. So having a background with that tool will definitely make it easier for you to understand where when I start talking about indexes, what that means. When I start talking about documents, what does that mean? And then lastly, OSINT. These concepts are OSINT concepts, so it does make sense that if you were going to benefit the most from this talk, you would have an idea of how this could fit into your overall OSINT procedure and process. So as I said, we're going to level set. This is kind of how I learn new topics, is I dig down to the point where I don't know what something is, and then I sort of build back up on that. So, example of that could be if I'm learning something about an LSAS dumping tool, I might have to go lower and lower until I get to, well, what is LSAS? What does it do? Not just from a security perspective, but from a Windows functionality perspective, what does this do? So what is data mining? Alert, it is a buzzword, so it can mean a lot of different things. Different people will use this in different contexts to mean different things. But in this talk, I'm going to use data mining to refer to any form of large-scale data processing, which would include collection of data, extraction of data, warehousing, which is sort of like long-term processing of the data, and then analysis, which would cover, for example, we're going to talk about YARA, which is data analysis, or great for data analysis. Collecting data is pretty easy. So this is that first task we talked about. Scraping from the web, relatively simple. Scraping from APIs or just generating your own data through syslog or whatever is pretty easy. Extracting value or extracting fields from the data is more difficult. Typing data is difficult. We'll talk about specific types in Elasticsearch that make PasteHunter great or terrible depending on how you use them. And then analyzing that data is even harder. So building a statistical model or something based on the data to say, let's build a metric that tells us when something good happens, when something bad happens. And then lastly, creating an actionable data flow, sort of analysis. In depth is the hardest thing to do of all. And just as an example of why this is hard, or to prove that it's hard, look at an EDR. It has access to all of the information or most of the information on the endpoint. It has access to user actions, it has user process information, it has file information, and yet it's very difficult for EDRs to make authoritative snap judgment decisions about whether a process is good or bad. They kind of sit and wait for a chain to build of bad or malicious or suspicious patterns, and then they act. So, that run DLL32 process that's been running 100 times and then one time it's malicious, it's very difficult for these tools to automatically make decisions based on data flows. And that applies to any sort of data processing flow code that you write. It's difficult to say, let's do something based on this data flow, and it's always going to work in every scenario. That's the most difficult part of data mining. So what about web scraping? This is another concept that's sort of more specific to data mining, but it just refers to extraction focused on web pages. So we're collecting data and we're extracting it in its web content specifically. So the techniques that is common for web scraping are to retrieve the page, parse the HTML. That's the simplest possible way. We're going to cover that with the tattoo shop example. Request and Beautiful Soup are two libraries in Python that can do this really easily. Then you can also use a scraping library that's sort of an end-to-end library. So it will establish a session, maybe it'll authenticate for you, it'll download the data you want and parse it. So it's kind of more of an end-to-end integrated solution. Scrapey is an example of a library that does this. These libraries are very powerful. They're also more difficult to use. And then lastly, to simulate a real browser and user action on a web page. So Selenium can do this. There's a web browser library in Python that can do this. This is the most complicated to build, but it is extremely powerful because you get access to data that you wouldn't otherwise be able to access. Like the DOM is inaccessible from requests, for example. Or a lot of web pages now will require the user to interact with the page to grab the content. So, if you have to click a drop-down menu that says click profile or view profile, it's going to be difficult to facilitate that with a scraping library unless there's a specific hook or tag that always applies to that attribute, which is rare. And then just some tips about web scraping. At scale, if you do it at the scale of, let's say, millions or billions of documents, you should expect countermeasures when you're web scraping. There's CAPTCHAs, there's bot detection, there's IP address blocks, there's rate limiting. It's just one of those things that sites don't necessarily want to be scraped, even though it's something that every other site or every other large company does to every other company. It's not necessarily something that is going to make the admins of the site super happy. Honor among bots, that's just sort of a phrase that I came up with. Basically, follow the rules, at least read robots.txt on the site you're scraping, at least think intelligently about how often your tool is going to run, how much traffic it's going to generate, or you will be blocked. We can sort of make the whole scraping architecture and world better by not smashing sites with millions of requests. Scraping is totally legal, but if you use it, it's all about intent. If you use scraping maliciously, or if you use scraping to sort of undercut a company's intent, it's likely that they will come after you. And despite the fact that it's legal, it might not be worth you fighting that lawsuit to to prove that your scraping is totally above board. So just in general, be respectful of site owners when you're doing this. And just as an interesting note, there are third parties that actually do scraping as a service. So one that I've worked with is Bright Data. Appify does this. You can actually, as a service, say, I'm going to connect to this. Give me someone's Instagram profile, and they will actually do it for you and charge you a piece of that. So if you don't think web scraping is important, these companies would disagree with you because their entire business model is based on web scraping. So getting tattoos using Python, kinda. This has been a problem that I have had. So the best artists, the best tattoo artists, are often booked for months or even years. As you'd imagine, they can only do one tattoo at a time. There's a lot of people that want tattoos, and so this leads to the books just filling up for an extended period of time. Also, I think a lot of tattoo artists are uncomfortable with booking 3 years in advance, right? Maybe they want to move. It's just everyone handles it differently, but it's just weird to think about having thousands of people in the queue waiting to get a tattoo. So a lot of them periodically open their books to fill gaps and then close them. And sort of the intended way that you're supposed to do it is to monitor their social media or their websites, watch for updates, and then when things open, you submit your tattoo idea or you get a booking. There are other artists that will do things like lottery systems or like entries and drawings and things. And then on the right there, that's a screenshot of the page specifically that I am scraping. It just says the books are closed, no requests. When they open, submit an idea. So that makes me sad. But there's a solution, which is automation. The GitHub link is basically just a simple example. It's less than 100 lines of code. We're going to walk through it piece by piece. You don't necessarily have to go and download it and modify it. You can, absolutely, but it's just designed to be an example. It uses requests in Beautiful Soup 4 to scrape the site, determine the state of the books, whether they're open or closed. If the books are open, it will notify the user with pushover, or other things will trigger pushover as well. And it stores those results in Elasticsearch. It's hacky, as you'd imagine. I wrote it in a solid 1 hour or so, so it's not exactly going to blow anyone's mind, but it is a good example of what you can do with scraping. So we're going to walk through some of the code here. I know this might be too technical for certain people, but I do think it's worth talking about because these concepts in this code is very similar to how PasteHunter works. And if you were to write a custom code parsing code, this is pretty much what you'd want to start with. So first we make the request to the URL. We add headers. Those headers are just a real user agent header. And then we parse it. We're using the LXML parsing library, which is sort of the recommended fanciest parsing library, the fastest. It is an extra dependency, but I think it's worth it. We create a content hash of all the div attributes with the paragraph class. Or all the div elements with the paragraph class, which is an incredibly useful sort of failsafe that I've built in. That basically says, if this changes, if the content within these paragraph divs changes, I want you to notify me, because I might mess up with regex. As you'll see later, my regex is kind of janky. So this is just sort of a failsafe. In general, when you're building this kind of stuff, you want to build in failsafes because you can't guarantee that you've covered every edge case. The web is sort of the wild west of content. The web design person can decide, nope, we're doing an overhaul, everything's going to change, and then your scraping tool doesn't work anymore. So it's good to just know, oh, something's bad or something has changed. You need to either reevaluate how your code works, or select a new element to go after, or whatever. This is what the content on the site looks like if you view the HTML source. So you can see here, font size 5, that's not exactly a useful wrapper, but above that we have the class paragraph, which is great. This is going to be tailored to your site. So you're going to have to go look at the DOM, look at the HTML source, figure out what are you looking for, what aren't you looking for, and then parse based on that. This is more difficult than it sounds, which is why I would recommend being greedy with your data collection, meaning consider just downloading the entire HTML file and saving it as a blob. Elasticsearch makes this really easy. Basically, if you don't know, if you're relying on your parsing code and your parsing logic for something that's important to you, like collecting this data, download all the data and you can worry about reparsing it later if you happen to mess something up. And like I said in the last slide, build in fail-safes. If your code fails, you want to find out about it, either through some kind of active message or through some sort of notification. You want to assume that your code is going to fail when you're building this kind of stuff, because the truth is parsing is tricky and there's a lot of edge cases that are hard to cover in a short period of time. Then we do some regex and logic. So this is some really simple regex. We look for the literal string books closed. If that doesn't exist, or if that does exist, we say it's not open. Otherwise, if we don't find the books closed string anywhere, we look for the string books open. If that exists, we say the store or the shop is open. Otherwise, if we can't, neither of those strings are present, we basically say something's wrong. I can't find the strings I'm looking for. Let's exit and send a notification that says, hey, go check this out. You probably should fix your code. And yes, everyone should learn regex. I definitely should learn regex. Don't trust it completely, like I said, and think through the logic. Mine is questionable. I'm sure you can imagine some edge cases in which this fails. If you remember from the first slide where I showed the screenshot of the tattoo site, that there's actually both strings are present, so that's why I had to code in that additional logic. It says books open and books closed on the same page. That can definitely happen. It's not like they're writing an API for whether the books are open or not. Structure and indexing, this is sort of the last piece of the code that we're going to go over. We create a class for the ShopState. I think creating Python classes or any language classes is really helpful just to sort of get you an idea of what data you're expecting, what fields you're expecting, what types you're expecting, that kind of thing. It's just good to be able to define that clearly. They also make working with your data easier. You can build functions that process the data. You can build reference, get object, set object, that kind of stuff is really useful for working with, especially once it gets bigger and you're parsing huge chunks of, or huge lists of elements and fields. It's just easier. And then also when you're working with JSON, you can directly convert to a dictionary. I will say that only works with like mostly string oriented types. If you're doing heavy nesting or other dictionary or object, that can fail, but it's just good to sort of think of your data as JSON in the program, not just in the encoding, if that makes sense. And then we're going to send the data. So we determine the shop state. That's just creating the class object, which all those attributes were set above based on what I already showed you. Check time is just UTC datetime.now, super simple. And then we log the message to standard out, because I assume my code is going to fail and I want to see when it fails what was discovered. Then we try to index it. So this is just a simple error handling. We try to index it to Elasticsearch based on the index name we set. This ES object is just an Elasticsearch code object that we created earlier. That is just a session to an Elasticsearch cluster. And then the body of which is just the document, is just the JSON, direct to JSON conversion of the current state class. So current state instance of that class. So super easy. And then if that fails, we say there's an error indexing to Elasticsearch, but we do continue. So we do keep going. And it runs every 5 minutes. So far the results, I have not gotten a booking. You can see here it was I've been doing this for a while now, since I built this program on May 9th. I guess that's not that long in the grand scheme of things, but I haven't gotten a tattoo yet. I haven't even gotten a booking yet. So just going to let it run. But What I have gotten is peace of mind. So I'm the kind of person that I struggle with having a background task like this running for an extended period of time. I think humans in general are bad at monitoring things. That's why we build these tools that monitor things for us. But now I don't have to think about it. I don't have to worry about, oh, I need to check her Instagram or whatever and see if they're open, see if I can get this tattoo. I just assume that when this notification comes across, I'll get the booking because I'm probably going to be the first one to know, honestly, or one of the first people to know because it's going to be instant. Um, and I'm also capturing the data for the future analysis, which I don't really have plans for, but it's just good to have. This is maybe my internal data hoarder coming out, but I will have timestamped data of every time the shop was open, what the content hash was, etc. Um, I could build a metric that says that what percentage of the time the shop is open in a given month or something like that. It would just be depressing right now because it would just say 0, but it is possible. So that's a simple scraping example. I hope that sort of gives you an idea of how this code works. Like I said, this will translate almost directly to the PasteHunter code model because it uses almost the exact same sort of model to work. So what about the whole security thing, right? I guess apparently this is a security conference, not a tattoo conference. So we should probably talk about security. So enter PasteHunter. Here's the GitHub links. It was built by Kev the Hermit, an extremely awesome dude with a DFIR background. It was built for a blue teamer, so that's sort of an interesting fact. I obviously, as a red teamer, I think it's super useful as well. I think it'd be useful for anyone who's interested in this kind of data. It uses Python and YARA. Those are sort of the two main languages on the repo. It's Dockerized, which is nice for installation and getting it up and running. And then the sort of architecture of how it works, it scrapes data from the inputs, which could be Paceman or GitHub. Then it scans it with YARA, and then it sends it to the outputs. So that could be Elasticsearch, could be Splunk, or just a flat file. It also sends notifications along with the, storing the data. And then lastly, as sort of a post action, it can run the binary content it finds. A lot of people, as you'll see later on, people do post binary content to paste sites, and it'll do that in a sandbox or do other follow-up actions like it can encode it. So my experience with the tool, I started using this tool in 2017. There are 20 plus million total documents in my personal Elasticsearch index. I run this in my home lab. I have it's like 600 gigs sort of in documents. There's actually a lot more because Elasticsearch expands the size with replicas and things like that, but it's 600 gigs of documents, which is a lot when you're talking about just text data. And I want to give everyone a fair warning. If you are going to go after paste sites, as the talk title implies, paste sites are sort of the dumpster of the internet. There's a lot of data, as you can see from the picture on the right. This is me trying to extract useful data from a paste site. There's a lot of data, like probably expect something like 1 million documents a day if you have every source enabled. That's like raw. Obviously, a lot less will be actually stored if you store only YARA matches, but the volume of the data can be staggering if you actually have every source enabled. And also the content, it's a dumpster, so expect some disgusting things. There's definitely some questionably legal things. There's sort of a, people just put whatever they want on there. So just bear that in mind. I wouldn't necessarily, if you're doing this in an enterprise context, I wouldn't store all documents just for liability reasons. I would filter only YARA matches. So you can actually blacklist content you don't want to see and filter content that you do want to see so that you're not just indexing every single thing that anyone posts to Pastebin or wherever. So here's a list of the inputs and the outputs that are currently supported in the PasteHunter repo. So Pastebin Paste, for those that don't know, Pastebin's the biggest paste site, probably, or the most well-known paste site. What I mean by paste site, if you don't know what that is, you're just pasting data of any kind. I guess it has to be text data, but it could be encoded text data to a site, and then when you paste it, it generates a link, and you can share that link with other people. So if my Minecraft client crashes, I can paste that log to Pastebin and then share it with you, and you can be like, it crashed because you didn't have enough RAM or whatever. That's sort of the basic case of a paste site. Public gists are supported as well, which a gist is just sort of GitHub's version of a paste site or a paste. GitHub commit log, there's a public commit log that anyone can see. That is an input as well, which is quite the fire hose. That, as you'd expect, there's so much that gets updated in repositories every day. ix.io, this is actually a sort of interesting paste site where there's a Linux repository that you can download and then just pipe data into this. So you can pipe data into ix.io and it'll actually paste it for you. So it's really integrated into that Linux tool, so that sort of tempers and changes the way the data that gets pasted there. You can use the web client as well, I believe, but really it's tailored to this specific tool that pastes data there. There's also slexy.org and I think dumpz.com, which are both defunct. The sites are sort of shut down now, but this code is still there if you want to browse it or modify it. And then Stack Exchange all sites, which if you don't know what Stack Exchange is, first of all, how did you even make it to this talk without looking up how to attend a talk on Stack Exchange? That's what I did. But also, it's every possible topic. So it could be physics, security. The most common one is Stack Overflow, which is just sort of general coding questions. But it's basically people asking questions similar to Yahoo Answers, but a lot better. And you can actually index every site if you really want to. So you can say, pull all the results from the cooking Stack Exchange. Not sure what useful security information you would get from that, but it is supported. And then also anything you can code. So if you can use the libraries I demonstrated in the sort of intro to this, you can probably code a PasteHunter input. And then outputs, I already mentioned the SIMs, or whatever you want to call these, data aggregation platforms, Elasticsearch and Splunk. Email alerts are supported, Slack alerts are supported. That's for if certain rules match. It's not like you're going to output all your documents to email. That would be you'd fill up your inbox really quick. And then also you can output to flat files if you don't want to set up these complex data aggregation frameworks like JSON or CSV are supported, or syslog even. So, and then lastly, you can also just post to a webhook when actions happen. So you can say like, send me a Teams message or a Keybase message or whatever supports webhooks, and then do a thing. And then obviously, it's not really specifically an output, but there is, sandbox support, so that certain documents can be output to sandboxes as well. So we talked about YARA already a little bit, but just to go in depth on what it is, it's actually built by VirusTotal for malware sample identification, which means it can do text identification in its sleep. It's kind of like Regex on steroids. It's really useful and really powerful, and I would highly recommend pretty much anyone that's working with data classification learn it. It's easy to grasp the basic concepts, as you can see like here on the left. This is just a string that says tango down, and if any of it matches, we're saying it matches. So it's super simple to grasp, but to master, it's really difficult. If you look at if you talk to any DFIR person, building a YARA rule that comprehensively matches like a certain program execution or a binary is really difficult, especially with obfuscation. So it's really hard to master the logic of it when you get in depth, but it's really useful off the bat. The most common hits on YARA rules, you can go in the repo and see the full list. I'll explain and give examples of each of these, but the DB connection YARA rule is basically just looking for connection strings. That matches a lot. So that's 2.8% of the total documents I have match that rule. Email filter matches a lot. That's just lists of email addresses. DB structure matches a lot. That's just sort of strings that look like SQL formatting. And then SW bucket, that's like Amazon S3 URLs, other bucket URLs, just looking for potential bucket exposure. And then I would say overall, probably 80 to 90 or even higher % of documents don't match any rules, which means they're doing their job. They're filtering out unnecessary data. We talked about drinking from the fire hose. It's great to have all these filters. And you can have multiple matches per document. So you can say it matches core keywords, it matches a custom one I made, it matches this. And obviously, if you chain together a bunch of matches, you can get really, really specific with the data that you're looking at. This is just a good way to filter down that fire hose. I would highly recommend building your own custom rules. So here's one that I built. Super basic. It just looks for the string optiv, optiv security, or optiv.com. If any of them happen, it matches. So just kind of a good way. You could obviously build this for your company and say, oh, someone pasted something. Looking at the sort of data that this hits on, this picture on the left is not an Optiv match, but it's another custom rule that I made. This matches a lot on like GitHub repositories or blog posts. There's like news feeds that get posted to GitHub. So it doesn't match a lot, but it is always interesting when it does match. It's interesting to see what it is. If in the possibility that if maybe Optiv were to get breached and someone were to leak a bunch of Optiv email addresses, I would know about it almost immediately if they pasted it to any of the sites that I'm monitoring. And eventually it would probably get pasted anyway, so I would find out. If you're building these patterns, since I recommended doing it, here's how to do it. I would recommend storing all the paste for a short time and just browsing through the feed and saying what could be useful. You can do raw text searches and things like that to say, if I search for the string Optiv, does it ever come up? No? Well, that's up to you to decide whether it's a useful filter or not, but it's just good to see the cases you're going to be testing against. It's really difficult to test a rule without knowing what it would be matching. And also you can browse popular pastes. You can search for Pastebin or on GitHub you can actually search for strings and they have a built-in search, which is really nice. So you can look at that and then take the text and then run your YARA rule against that text. On the right, this is an example. I actually made a file sharing, so it just looks for basically these file sharing sites and make sure it's a URL. This is just an interesting match of someone posted a 33 million subdomain word list, which that's a lot of subdomains. I'd rather just use a mass, but hey, that is cool that I could go download that and use it in my operations. I will say this has been surprising with the data that comes back, and we'll get into that. So here's an example of a DB connection string. I've censored this. I don't think it's particularly sensitive, but it has an actual username, a password, a host, and then it creates a SQL Alchemy object to connect to this database. I'm not sure if this is live anymore, if this paste even exists anymore, but you can imagine if you were doing a gig and this was posted relatively recently, or even like sometimes these are valid for years, you could just log into this database and now you have, first of all, something that the client's going to be amazed that you even found this, and second of all, potential way in. If this database has administrative privileges or if it's running as a privileged user and you can use it to pivot or whatever, that's a mind-blowing, 0-day or whatever APT level attack scenario that the client's going to be amazed that you're able to pull off. And, it's a good story to tell anyway. Even if it doesn't work out, it's still, at least worth chatting over your next round of beers. Email filter. This one is just a list of email addresses. Code dumps are common hits on these email list leaks. People post like previews to the data they've breached. This is, I don't even know why someone would post this, but this is just an SES configuration to send a bunch of weird emails to a bunch of people. So it might be a marketing email. I don't know what it is or why anyone posted it. Probably some back-end dev got confused and needed help, so he posted it. If your company email was posted in here, it might be interesting, but this is a relatively common match. SW bucket, I mentioned this. Just looks for URLs. These matches are often combined with AWS API. It is false positive prone. This was sort of a gem that I discovered that is sort of interesting. This is like it's just a JSON object, but it's a log of a fax being received. It gives the number that the fax was received from and the number that the fax is sent to. But more interestingly, this S3 URL, I didn't test it manually, but it had a password in it. It looked like a totally valid S3 URL. Again, if this had client-related information or if it was your company's information, could be sort of notable that I can just look at a fax that someone sent your company. You could have data exposure on Pastebin that it doesn't require anyone to even target your website. It's literally a full third party that has data exposed on it. And you might not be able to get the paste taken down or get the AWS credentials changed or whatever. This is a pretty rare, it is false positive prone, but I think it's worth keeping specifically, look at this example. It's worth keeping it just for this kind of stuff. Ducky code. This is a really rare one, like 100 documents a year or so will match this, but it is funny. It's literally just Ducky Script. So you can catch your next vendor with terrible OPSEC. If anyone posts a valid, real Ducky Script to Paceman, they have the worst OPSEC, or this is actually posted to ix.io. If you find a vendor, out of curiosity, if you were to run this and establish a beacon to, pentester.com, it would be pretty funny to sort of say we found your beacon before you even used it on us. That's obviously an extreme lucky scenario to get into, but it is also potentially interesting because you can see what other people are doing, right? Any red teamer would know what this is. It's just simply creating a PowerShell. We're using the Windows key. We're running PowerShell. Then we're running this, encrypted payload. So very simple one-liner. Why did someone post this? Probably just for testing purposes, just as an example to say like, hey, go run this payload. Here's the class I'm teaching or whatever. But if it was valid, it could be a very easy win for you. Password list, pretty self-explanatory. List of compromised users. These are also really rare. I think people over time have sort of realized they can monetize this, and so it doesn't get pasted much anymore. If you look back at like 2017 when I started running this, it was almost every week you'd get one of these, but now they're much less common. This is someone posted all these password one credentials to GitHub. I didn't validate any of these. I have no clue, but there was emails in there that looked legitimate. So I guess someone might have a really terrible password for their email. Base64 exe. This is literally a base64 encoded exe binary file. So we talked about sandboxing. You could do some interesting sandboxing things with this where you decode it and run it. As you can see, catch your next vendor. Is this staging? Is this staging? Like they're just posting their encoded payload to GitHub. As much as it sounds interesting to pull a payload from GitHub, that sounds like a cool staging technique. Because it's public and it has to be public for your payload to work, potentially not the greatest idea. And obviously this is proof of why. So I wanted to talk a little bit about the Paceman Scraping API. If you are in the Twitterverse, you probably had heard about this, but in 2020, in April 2020, they basically said, we've discontinued the scraping API, no more scraping. People were using it for commercial purposes and it's prohibited. Then they obviously got a lot of backlash for doing that. And then they posted about a few weeks later, never mind, it works for people that have pro accounts. And we made a change, which it's very unclear what the change is. But in general, from where I sit, there's a lot less data available. There's two issues I linked here from the PasteHunter repo that explain sort of the problem, the solution, how they got it functioning again. The API does live on currently, although pro accounts are not available anymore. So it's kind of like you have to have it. Otherwise, you're kind of out of luck. And now Paceman is sort of promoting this enterprise API, which I reached out to them and asked about pricing and other data, but I haven't gotten a response back yet. But it could be useful, might be worth looking into if you're really interested in these data. So you might be asking, hold on, is the tool PasteHunter with no Paceman? They need to change the name. Well, okay, first of all, if you have a better name, maybe submit a pull request. No, I'm just kidding. But the name PasteHunter, it actually works pretty well with no Paceman. There's GitHub, like I said, public gist, public commit history. That's two huge data sources that are really common. Other Paste sites, ix.io, we already mentioned a few different things that got posted there. And then Stack Exchange. And you can also code your own. So if there's other sites that you find like Ghostbin or whatever, you can index them here. Just to sort of dial that point home, this is statistics of my documents that I've matched. This is only YARA matches, so I do store everything from Paceman because it's sort of a higher value source with the API being restricted, but this is only YARA matches. This is within a 1-year time frame of today. So in GitHub, we pulled 450,000 documents. That's a lot. In Gists, we pulled 66,000 documents. Selexi, that's still in the data, even though that site has been shut down, is 50,000. ix.io is 40,000. Paceman was only 17,000 documents that matched YARA rules. So in general, I think either I'm not seeing the data, which is possible because of the way they changed the API, or people aren't using Paceman as much. It's possible, people are sort of fair weather supporters of different sites like this, where since they alienated the community, they just said, we're not going to use you anymore. Who knows? But either way, this is the data. Most of it comes from GitHub now, so don't worry about not having access to Paceman. Any GitHub account with an access token can pull the data. I'm not going to run through setup of the tool itself. It's really easy to set up. The documentation is really good. If you want to set this tool up, it's quite easy to do. Just go to the document, go to the repository, clone it, install the requirements, and then run it. You will have to do some basic configuration of the settings.json file, but it's so easy. I didn't want to waste time talking about it. But I do think this stuff isn't really encoded or captured in the repo. So here's some tips about Elasticsearch. I would highly recommend making an index template because the tool doesn't have mapping support in Elasticsearch, meaning you can't define what the index will look like on the client side. You have to define it on the Elasticsearch side. And which here's the changes I would recommend you make. First of all, set store true to on the raw paste field, which what that does is that will tell Elasticsearch to store that field separately from the source field. So basically, this is just a performance enhancement. That will make processing the documents way, way, way faster when you're searching them because it won't have to recreate all the fields from that big blob of the document. Splunk has something a similar setting to this as well. And then for a setting on shard size, if you're using the weekly indexes, I would do 5 shards. It's about 10 gigs a week or so, at least the way I'm running it. And so you don't want to use just one shard for that. For string fields, when you're setting up these templates, text fields, there's just to go in a little bit on Elasticsearch, there's 3 different kinds, or there's probably even more, but there's 3 primary kinds of string fields in Elasticsearch. Text fields, keywords fields, and then wildcard fields. So text fields are analyzed during indexing. They're broken down into terms. So if you had a string like Optiv security, it would break it into 2 strings, Optiv and security. Then if you search for security, it would come up when you search for that document would come up when you search for security. For keywords, they're not broken into terms. So if it said Optiv security, you'd have to search for Optiv security to get the match. This can be analyzed after the fact. You can say like analyze the wildcard term on the keyword, but and that's native in Kibana. But if you were querying the backend directly, it would have to do that. It's built for sort of complete matches. And then recently they actually came out with, as of version 7.9, which is not that recent, but that is nice and recent, the wildcard field, which is built specifically it's built for like large error logs, but it's great for paste because it's built specifically to look for certain strings in a big glob of data, which is exactly what a paste is. If your email shows up 5,000 lines down the file, you don't want to index 5,000 emails as text fields, and you also don't want to potentially miss that data with a keyword. So this wildcard field is great. I would highly recommend this type for dealing with paste documents. And that would obviously apply to the raw paste field as a wildcard field, not the other. There's a bunch of other fields as well that wouldn't apply the wildcard field. And don't be afraid to reindex or just dump all your data out of Elasticsearch. I've done this a few times where I messed up something or I didn't have the settings right. I'm actually right now working through the process of reindexing all the historical pastes into that wildcard field mapping, which is obviously more difficult than it sounds, but the Elasticsearch dump tool is an NPM tool that also has a Docker container that's really useful for just dumping all the data out. So highly recommend checking that out. I want to talk a little bit about the future of pastes. As I sort of mentioned, paste site usage has dropped. In 2017, I was seeing probably 1 million hits every month that matched YARA rules or even more. And now it's probably more like 50,000. So it's been a serious drop off in the usage of these sites. That could just be to the tools. Maybe PasteHunter doesn't pull all the data from the Paceman API because the API is restrictive now. I don't know, but either way, I think in general that social media is sort of taking over this role of where to paste stuff. Now, if I need help from my friends, I usually just paste a big string in Discord and hope that someone will help me. Or maybe I just tweet it or I send it in my Telegram chat. That data is never going to be publicly exposed. It's sort of a rising tide of OPSEC or just rising tide of how people view data exposure. Paste sites now, maybe people even don't know about them or think that they expose data. I can tell you they do expose data, so that's totally fair. As far as how to crawl or scrape these tools, you can do some API stuff with these, but it's way more complex. You're talking about doing accounts, you're talking about usage tracking and actually building sessions and building networks of friends and things like that. It's way more complex. I guess the benefit of it is if you do use the API, you at least know what the data will look like. So that's a plus. I do think private sites and forums are still used, RAID forums, things like that, but they use really strong countermeasures against scraping. They use CAPTCHAs and Cloudflare and all kinds of tools that are built specifically as anti-scraping methods. This is just what happens when, this is why we can't have nice things, whatever you want to say. And then scraping as a service exists. I mentioned this before, but Appify, Bright Data, they will do scraping as a service. So it's a mainstream business model now. Every company scrapes every other company pretty much. It's open secrets. They don't like that people scrape them, but there have been examples of lawsuits and it's totally legal. There's also companies that their whole business model is data aggregation, basically running not PasteHunter, but running tools like this and then selling the data. So, ZoomInfo is an example of that, or there's a lot of intelligence companies that will sell you this data. It's pretty cool, but it's also, now it shows you how valuable the data is, that there's entire industries that are based on it. So I think overall, more companies are trying to monetize their own data versus just exposing it publicly for anyone to see. They're trying to sell you it versus just give it to you. I think data should be free. That's just my opinion. But legal status of scraping, touched on this a few times, but it is legal. There was a lawsuit where LinkedIn tried to sue a very small company that was scraping their data and selling it, similar to what ZoomInfo might do. And they won. The small company ended up winning the lawsuit, but obviously lawsuits cost a lot of money. If I got sued, I would shut down. Please don't sue me if you're watching this talk. Actually, no, I've never done any of this. This is all theoretical. No, I'm just kidding. But cease and desist have power still. If someone told me to stop scraping, I would have to comply. So final notes. This is just sort of a rebuttal or whatever you want to say. Can I search for this data? These are maybe frequently asked questions. Can I just search for this? Can I just Google this? So here's a screenshot on the right. If you search for paceman.com on Google, you get 448,000 results, which it's kind of crazy to say this, but I have way more data than Google, right? I have scraped way more document than 448,000. The only data that Google is going to care about is they only care about the pastes that get linked on other sites. That's sort of how their algorithm works, right? They're not just going to go scrape all of Pastebin and then find pastes for people. GitHub, and also Paceman doesn't have a native search. So you can't just go on Paceman and say, search for the string optiv. You can't do that. GitHub, you can search. GitHub's way more heavily indexed by Google because it's really useful. And GitHub has built-in search both for repositories and for gists. So you can search for strings and gists, and whether, I don't know how that search works. I didn't code it, but theoretically it should be functional. I will say, deletion and expiration of paste. When I went back for this talk, almost all of the YARA rule matches that I used as examples had been deleted. So people will paste something, leave it up for a day or an hour, and then delete it. But if you're there indexing the data as it comes across, you can get that immediately. And you can historically say this was posted from, October. It was posted on October 2017. As of now, it's no longer there. Takeaways in general, if you're not going to use this tool, which is totally fine, I think it's a pretty specialized tool. Here's some takeaways for you. Build good OSINT habits. Build automation. It goes a long way. So if you're going to collect the data, if you're going to go through the trouble of searching for it, finding it, collect it, put in the extra 20%, 25% of effort and actually have it be automated so that next time you want to scrape LinkedIn, that's a common one, or next time you want to pull a company's data from some website like Open Corporates or something, code an extraction tool that does it automatically. So you just run a script, it outputs the data, and then maybe it saves it as well. So you can build, these large profiles of data that are useful beyond what you might think at the time when you're searching it. And use tools to your advantage. So I definitely covered a little bit of how Elasticsearch can be used as an OSINT tool. I have a lot of other a lot of other knowledge about Elasticsearch that goes beyond just this tool. And I would basically say, stay tuned. I have a framework tool release planned for late 2021 or early 2022. Not 100% sure on when the tool is going to release, but it's basically taking all the tricks I've learned with Elasticsearch and adding a bunch of other data processing stuff with Spark and Jupyter. And it can do data breaches. It can do OSINT data like we talked about in this talk. So spoiler alert, I put my data from PaceHunter into this tool. And it can also do like big password lists if you have, a million credentials. Go ahead and put them in there. Or sorry, a million is nothing. A billion, 10 billion. If you have scraped data, it's great for that too. So, we talked about saving the raw HTML content of web pages. You could do that with this tool. So it's obviously not a net new tool. It's a sort of a framework tool of combining these existing tools, but it does have some interesting processing examples in code. You might even see my simple scraping example as part of the repo. So stay tuned. So lastly, I want to say thank you to you for attending my talk, to the PaceHunter repository maintainers and Kev the Hermit for designing the tool in the first place, and for all the people that answered all the questions I could ever possibly want to ask on Stack Overflow. So if you have questions, I'll take them now, and follow me on GitHub for that upcoming stuff I was talking about, or don't, but it's cool if you do. Thanks.